Okay, my name is Tyler Janetz. This is Physics 222, video homework 1. Objective saying I can use the electric field that varies with position to calculate the movement and position of a charged object through several, which is 2 to 3, iterations. So for my problem, I said say an electric field varies with 2z, 3y, x newtons per coulomb, and a 20-gram particle with a charge of 20 microcoulombs starts at the origin and has an initial position of 331 meters, traveling at 111 meters per second. And then we want to find the location of the particle at 5 seconds and 10 seconds. So we're going to use 5-second time intervals in our iteration steps. So first off, we're going to use our initial position to plug into our electric field here, stating, oh, by the way, these are just my constants that I converted to SI units. So here for a 5-second interval step, the first equation is F net equals QE. So I plug in the location into my electric field equation thing, and then I multiply that by the charge Q, and remember we converted that to coulombs. So then I do that and I get my answer of the net force in newtons. So then I find my final momentum, and I do that by using change in P equals F net change in T and manipulating that to get final momentum. And as you can see here, I have my initial velocity times the mass, and then I have my net force and my change in time. And then for that, I get my final momentum for this time interval step. And then I use that here to find my new position. And I use my new position by plugging in my initial position and adding that to the average velocity times the change in time. For my average velocity, I have my momentum, which I just calculated here, divided by our mass. And I do that, and then boom, I get my position of the particle at 5 seconds. So then, here, I do it all over again, but for 10 seconds. But remember, 5 plus 5 equals 10, so it's just another 5-second interval step. So I basically just repeat the process using my new position and plugging that into my electric field equation, and then I end up getting this as the net force for this time step, and then I do the final momentum again for this time step, and I end up adding all this together and multiplying it all together and getting this right here. And then I plug in that momentum to get my position, and I do all this jazzy stuff that I just did before up there, and boom, I have my position of the particle after 10 seconds. And then I can obviously just repeat this process over and over again, finding my net force by plugging in my electric field with my position, and then finding my momentum, and then finding my position. And I can do this over and over again using the 5-second interval steps, and that satisfies the objective that I can use an electric field that varies with position to calculate the movement and position of a charged particle throughout several iterations.